Yeah, so natural rubber is the linear polymer. Once you add sulfur, it becomes vulcanized rubber. And how does it become vulcanized? Because of formation of crosslinks. And these crosslinks, mind you, it was done by sulfur itself. Now this crosslink was by sulfur, this crosslink by sulfur. So I put S, right? So that way you know the crosslink is by sulfur. Okay. So that is what is going on here, and due to the crosslinks the elasticity is highly reduced. So the answer for that is, for that question, second part, okay, the answer is formation of crosslinks, okay, formation of crosslinks among linear chains, okay, of rubber through sulfur, of linear chains among linear chains of rubber through sulfur. So this whole process you just mention in a few words, right? Precise, to the point. Okay, formation of crosslinks among linear chains of rubber through sulfur. Okay, so let's go for the B part. Okay, so this is the second question, A part, right? What's the structural change? So they're talking about the structure. So you have to look at the from above. You have to look at it from above, right? Okay, so B part, okay, state two changes in the properties of natural rubber brought about by the structural changes stated in part A above. Okay, so now we spoke about the structural change. What was the structural change? The structural change was the formation. What was the structural change? The structural change was the formation of what? Crosslinks. Okay, so you can either say that in words, or you can simply, even for drawing like this, you get marked for that question, right? I forgot to mention that, right? Even if you draw it like this, you get some marks. Okay, so they are asking what is happening now. Just because you get some crosslinks, they are asking two changes. Now rubber has been converted from linear polymer to crosslink polymer, right? So they are asking the two changes that are brought about by this structural change that I already said in part A. Okay, so what are the two changes that you can see, right? I mean, you can't see here, but visibly what can happen. So when you practically think about it, I already said one, right? The first one is the elastic nature is reduced, right? The elasticity is reduced. That's the, you can take it that as the first answer, right? Decreasing in elasticity, okay? Decreasing in elastic nature. Okay, you can say that, okay? And you can also say that you're increasing the melting point, because when something becomes hard, the melting point is increased, because no matter how much of heat you try to put to something that's very hard, like diamond or something, it will take a long time to melt, right? So second thing is increasing, okay, my bad, increasing in melting point, you can say that also, okay, melting point. Okay, and the other one is, if the elastic nature reduces, that means hardness is increasing. It's becoming very hard, right? So the hardness is increasing, so increasing the hardness. That's another point. So they're asking only for two, but I'm mentioning every possible answer. Okay, so increasing hardness, that is another point. Okay, if you take the fourth point, what's the fourth point? The fourth point is, it is if it's very hard, that means it's resistant to wear and tear. It won't wear off or it won't tear off very easily. So that's another answer that we can take. Resistance to, or resistant to wear and tear. Okay, and then it is increasing the strength. That is another answer, right? Strength increases, right? Because if hardness is increasing, that means strength is increasing. It's logical, right? And it's also yielding to pressure or heat. So no matter how much of pressure or heat you supply, it's not going to wear off, or it's not going to change its structure very easily. Okay, yielding into pressure or heat is another answer. So one of the two you can write. Okay, so these are the answers for that question. Okay, Right, so now the C part. Now see this, just like I said, A part, B part hydrocarbons. Now C, you're going to directly to biosphere, right? They're asking to name one pollutant causing global warming and one pollutant causing acid rain which are added to air when vulcanized tires are burnt in air, right? The pollutants causing respective effects should be written clearly and separately. So, right, okay. Now they're asking, now this, since this is, what do you say? It is the lesson from, it's from the biosphere lesson now, right? A, B is from hydrocarbons and C is in biosphere, okay? C is biosphere. Okay, so I will not go into detail about biosphere, but I can guarantee this one point, this answer is very easy, right? How you can get is, even this, if you really know about environmental science, like, you know, if you have an idea, it's going to be very easy, but that's okay. Let's see, right? They're asking one pollutant causing global warming and one forming acid rain which are added to air and vulcanized tires are burned in air. So I already told you, right, what is there in rubber? Rubber, what are the constituent elements? Carbon and hydrogen, right? So usually it has carbon and hydrogen. But once you vulcanize it, what is another element that's added? Sulfur, right? So these are the constituent elements that's there in vulcanized tires that are burnt in air. So these are the possible constituent elements that can be found. Okay. So one pollutant causing global warming. So from this, what can you make? What can you make now from this? Now these are elements. Now, what are the compounds that you can make that will cause global warming? Global warming, when you think of the word global warming, you should mostly think of carbon dioxide, right? Right? So carbon dioxide is the answer for the one pollutant causing global warming. You can say carbon dioxide, you can write like this, or you can write in words as increasing global warming, carbon dioxide, right? Acid rains, when you think of acid rains, two compounds that form acid rains are sulfur dioxide and nitric dioxide, okay, that is NO2 and SO2, okay. So from here you can't see any N's, right? So S is the one that's contributing to acid rain, which is sulfur dioxide. It's okay if you didn't understand this part, because when you study biosphere, it will be very easy for you to understand. I told it to you because you can either say sulfur dioxide or you can say oxides of sulfur, right? So one of the, these are the answers, okay? This is for global warming, this is for acid rain. Okay, so B part, right? I'm going to skip in B part. Now let's go to B part, right? B part, I'm going to skip the final, the final one, whether it's exothermic or endothermic, I'll just let you know the answer, okay? It's the book one, the last lesson, okay? The final part, the fourth part of the B question. That is about endothermic, exothermic reactions, right? When you study the lesson, I will explain, because that's like a whole different topic. Okay, so I will skip the final part, okay? I'll just tell you the balance equation, and I will also tell you just whether the reaction is exothermic or endothermic. So later when you come back, once you study the lesson, it will be easy for you to figure it out, okay? Right. So now they are saying LP gas cylinders used for domestic cooking mainly contain propane and butane. So this fact, now see, in this essay, they have mentioned it as a fact. But can you remember one of the MCQs, they asked what are the elements in the LP gas? It was something new to us then, right? So I think it was in the 2022.